Hi, today I'm going to present the details of Naïve Bayes algorithm. So as it is clear that from the previous lectures that I have explained the basics of Naïve Bayes algorithm. Naïve Bayes algorithm is one family of simple probabilistic classification algorithms in machine learning based on Bayes theorem. It is called naive due to its strong simplification assumption that all the features in dataset are conditionally independent of each other given the class levels. Despite this simplification, naive Bayes algorithms often perform well in practice, particularly in tasks like text classification, spam filtering, and sentiment analysis. This is the figure to represent the naive Bayes in machine learning, that is for classification. So now if we want to enter how naive Bayes algorithm could be understood, so it is supervised learning algorithm and it is one of the simplest supervised classification algorithms available based on the Bayes theorem. Bayes theorem relates the probability that a certain event could occur under certain circumstances with the probability that circumstance is present once event class has already happened and the ratio of the probability. So here you could be familiar from the previous talk that there is posterior probability, likelihood, class prior probability, then predictor prior probability. So this equation is quite simple equation which you need to keep in your mind that how it could work and how the mathematical equation could be written in code or in when you are writing by hand over somewhere on the notebook or on the PPT. Now the same thing could be seen here. So how it could work when you apply this classifier, naive Bayes classifier, then these objects which are mixed with triangles, square, and circle could be classified. And this is very easy way to implement your classifier by writing your own machine learning code to classify these objects into different groups or into the specific classes. For example, the class of triangle, class of square, class of circles. Now, how it could work in the algorithm? So you need to train the data with these three types of classes and then go for machine learning algorithm implementation, that is naive Bayes, and then classify it and go for final prediction and conclusion. Now, if you want to see the same thing in slightly different way, then it could look like this. For example, text data mining from the documents, then feature vectors, set of metrics, then machine learning algorithm and certain labelings, new text, and then predictive model could work to predict the expected labels and final conclusion. Now, if you are working on spatial temporal data, then what are the algorithm which you can use it for prediction? Then, for example, support vector machine SVM, naive Bayes algorithm, then here propose naive Bayes, and then go for prediction for present time, future time, then other deep learning model could also be used for further exploration. Now, what are the naive Bayes classifiers? Optimal naive Bayes, then Gaussian, Bernoulli, then multinomial. These are the four naive Bayes which you need to remember and keep in your mind that there are four different types of naive Bayes which could be used as a classifier for your machine learning algorithm. Now, in case if you are just starting here and you just want to learn how to implement and write naive Bayes, then you need to know these six points. First is what is naive Bayes algorithm, how naive Bayes algorithm works, what are the pros and cons of using naive Bayes, then applications, then steps to build a naive Bayes model in Python, R, or MATLAB. tips to improve the power of Naïve Bayes model. Then this is the simple feature. If you are working with a case or as a case study, here you have how to classify the flu and the probability to have certain flus. By the way, you need to remember true positive, true negative, false positive, false negative. These are the things which you will always encounter while you are working with data science. And then here the predicted probability is 9% probability that someone could have flu. This is how naive bias could be implemented. Then first step, if you want to learn the basics of naive bias classifiers, then it belongs to a family of generative learning algorithm aimed to model the distribution of inputs with a specific class or category. Unlike discriminative classifiers such as logistic regression, it does not learn which features are most crucial for distinguishing between the classes. It's widely used in the text classification, spam filtering, and recommendation system. And this is one of the finest way to know the naive Bayes classes. Now, what is naive Bayes algorithm? Then this algorithm is a classification technique based on Bayes' theorem with an independent assumption among predictors. In simple terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. The naive Bayes classifier is a popular supervised machine learning algorithm used for classification tasks, such as text classification. It belongs to the family of generative learning algorithms, which means that it models the distribution of inputs for a given class or category. This approach is based on the assumption that the features of the input data are conditionally independent given the class, allowing the algorithm to make prediction quickly and accurately. Then this is the working model on right side. The equation will remain intact as I have mentioned earlier, and then the model could look like this: likelihood, data, prior, and then Bayes theorem, then posterior distribution. Now, the brief review of the Bayesian statistics. This I have already discussed in details. So, for example, Bayesian statistics, conditional probability, Bayes theorem, Bernoulli likelihood, then inference. That is three different things: Bayesian statistics, Bayesian stat inference, and test for significance, where you can go for p-value, confidence intervals, Bayes factors, high quality intervals. So these are the summary of the Bayesian statistics, which you need to be familiar. Now, examples of Bayes algorithms. For example, if a fruit is red, round, and about 3 inches wide, we might call it an apple, even if these things are related. Each one helps us to decide it's probably an apple. That's why it's called knife. A knife Bayesian model is easy to build and particularly useful for very large data sets. Along with simplicity, Naïve Bayes is known to outperform even highly sophisticated classification. Now, this equation you need to understand again and again. I'm saying, what is posterior probability? What is the prior probability of the class? What is the Px upon C, that is the likelihood, which is the probability of the predictor given class? Then prior probability of the predictor. These are the terms which are in this mathematical equation. These four terms you need to be familiar. And then now it comes the simple sample projects to apply knife projects. For example, you can go for HR analytics, where you need to define the objectives, then go for data collection, then go for data preparation, data analysis, interpretation, and insights, communicate findings, action planning and implementation, monitor and evaluate. Now, how do Naïve Bayes algorithm works? This I have explained in details, but In general, you need to go for summarized, convert the data set into a frequency table, something like this, or matrix table, then create likelihood table by finding the probabilities, then go for use of Naïve Bayesian equation to calculate the posterior probability. Now, this is the working model of Naïve Bayes algorithms. The left side figure is representing the summarized form. Right side figure shows you kind of pseudocode for the working model of Naïve Bayesian algorithm. So, for example, here again, three steps are there: data set, handling, training stage, and inference stage. Then now you can go for some simple application. For example, the players will play. If the weather is sunny, is this statement correct? Then you need to think with this algorithm. So, for example, rainy, sunny, cloudy, something like this. Cricket, playing cricket? No, yes, no, yes. So, this is how you can write the algorithm and decide. Now, what are the pros and cons of the Naïve Bayes algorithm? Then, in summary, you can say it is pros. The positive thing is it is easy and fast to predict the class of the test data set. Then, when assumption of independence holds, a naive Bayes classifier performs better compared to the other models like logistic regression, and you need less training data. It performs well in case of categorical input variables compared to the numerical variables. What are the negative points? It is also known as a bad estimator, so the probability outputs from predict probability are not taken too seriously. If a categorical variable has a category which was not observed, in the training data set, then the model will assign 0 and will be unable to make a prediction. And it is the assumption of independent predictions. So these are the negative points and positive points. Now the applications of Naïve Bayes algorithms are real-time prediction, multi-class prediction, text classification, spam filtering, sentiment analysis, recommendation system. The same thing could be seen here. There are 6 major applications which you can see here: real-time prediction, spam filtering, multi-class prediction, sentiment analysis, text classification, and recommendation system. Then, which application of Naïve Bayes classifier should be used for where and where? For example, spam detection, sentiment analysis, document classification. Spam detection effective in identifying and filtering spam emails. Sentiment analysis analyzes text to determine emotional zone or tone. Then document classification categorizes documents based on content. Now, how can you build the model of Naïve Bayes in Python or R? This is now, if it is what we have introduced, if it is clear, you have understood, you can write it with a simple code in few lines. And before you write, you need to have such kind of prototype on your computer or on a printout, and then try to think while you are writing the code in this model way or prototype way. And the code in Python may look like something this. So for the entire code Naïve Bayes algorithm implementation, that is what you can see in just few lines. Python can write the code, and you can write a code as a model for machine learning algorithm by using Naïve Bayes model. So tips, what you need to improve, and these are some of the basic things. So data handling time, data type, classification, file type, all these things you need to think. And then file data conversion, file conversion, remove correlated features, something like this. Naïve Bayes classification, classifiers has the limited options for parameters. So you need to think about parameters. Then you need to think about some combination techniques. So this is how you can improve it. And finally, you can conclude that Naïve Bayes classifiers are used for classification, and then it is quite simple to use and easy to make conclusive predictions. And if you somebody is asking what are the key takeaways, what you have learned from here, then you can say Naïve Bayes algorithm is one of the most popular and simple machine learning classification algorithms. It is based on Bayes' theorem for calculating probabilities and conditional probabilities. You can use it for real-time and multi-class predictions, text classification, spam filtering, and sentiment analysis, a lot more. Thank you very much for today, and I hope that you can subscribe and continue with us to learn more and more in data science, which I will continue further. Thank you very much.